I think you noticed that it is quite hot outside, so here's a summer project that you can do. In this video, I'll talk about cleaning up this fan. And I'll do this in a scientific way, where I will show you how scientific method works. Science is very exact, or at least tries to be. Most scientific endeavors start with observation. For example, I noticed that this fan is not blowing as it was new. After this observation comes the question part. So I have two questions. For example, the first one would be the fan blows slower because it's dirty, and another question would be the fan blows slower because it's old. I can discard the second one because the fan is rather new, so I will test the first question. After I have the questions, then I'll make a hypothesis. In this case, this would be that dirty fan produces significantly less airflow than a clean one, where this significant usually refers to a number. Let's put in our case 5%. Now I can work on my experiment. What I'm gonna do is test the airflow. I can always say that fan feels weaker, but science doesn't care about my feelings, and having me as a measurement for my experiment, it's very flawed science. That's why I need experiment. To do this, it would be great if I would have a anemometer, that's a wind speed sensor, but I don't have one, so I'll use a regular PC fan that has a DC motor. I will attach this DC fan to my testing fan, and the actual fan is this dirty. You can see the residue on the blades. I am attaching testing fan from a PC using zip ties directly on the outer frame of actual fan. This way, both scenarios, where the fan is clean and where it's dirty, will have the same setup. This is the basic circuit that I have. It's simply filtering out generated noise, so I can have a smoother line on the oscilloscope. And here are the actual results. I'm plotting the voltage on my oscilloscope. So for the level 1 dirty fan, it's 9.6 volts. Let's zoom in to the level 2. So the voltage is 13.0, and the fastest speed gives out the voltage of 15.6 volts. Here I will have the clean once I actually do the cleaning of the fan. I'm just removing the outer frame. You can see that the fan, measurement fan, is still attached, and nothing, just soap and water will clean the blades, which I dry them, so make sure you don't put the wet blades on the fan. And I will put back the outer frame at the same position as it was for the dirty fan in the beginning of our measurements. And here are the results. For the first level, it's 12 volts. Let me check for the level 2. So the voltage is 15.2 volts, and the level 3 speed is, let me just focus, it is 17.6 volts. So the difference between those two values are 2.4, 2.2 and 2.0 volts. If we express this as a relative, we get increase of voltage compared to initially 25%, 16.92 and 12.82%. 25%. That's way more than I expected in my hypothesis. This only means that it is a bit pessimistic. Nevertheless, the whole experiment gave quite interesting results. This doesn't mean that the experiment is perfect, quite opposite. It's very flawed because of, first of all, equipment is very old, not precise enough, and the setup itself. The proper setup would certainly include multiple levels of dirt per blade and multiple fans, of course, and only then we can see a proper relationship between level of dirt and the airflow. Maybe it's linear, maybe it's exponential. It would be interesting to see. In the end, scientific method states that all research should be published. So let's assume that I published my research in the form of this video, where any one of you can recreate the whole project, recreate the experiment using your own fans, your own setup, and you can get a different or similar results. If you get a similar result, then it means that we came to the same conclusion. If you get a different results, my conclusion might be wrong, which is great, as long as we are making proper conclusions. To summarize, just go ahead and clean your fans and thank me later. See you in the next video. Bye.